Hey, what's up? It's Jake from Nimbus DevOps, and now we're going to go over running multiple instances of your app in Kubernetes by scaling it out. So, in the previous section, um, we created a deployment, exposed it via public service, and the deployment created one pod running for the app. And when traffic increases, you'll need to scale that app to keep up with the user demand. And so, scaling is accomplished by changing the number of replicas in a deployment. So it's pretty self-explanatory. I'm not going to go over it and use diagrams and stuff, but when you scale this up at this deployment, it ensures new pods are created and scheduled to nodes within whatever available resources you have. The scaling increases the number of pods to the desired state, and Kubernetes also supports auto scaling of pods, but I'm not going to do that right now. Scaling to zero is technically possible and will terminate all the pods in a specified deployment. Running multiple instances of an app will require a way to distribute the traffic to all of them, and services have an integrated load balancer that will distribute network traffic to all pods of an exposed deployment. And the services will monitor continuously the running pods using endpoints to ensure the traffic is only sent to available pods. So once you have multiple instances of the app running, you'd be able to do rolling updates with zero downtime, which I'll go over updates in a separate section. So let's look at an interactive terminal. I'm going to clear this out and see how we might do this. And let me move this over in a different screen so it's easier for me to see both. There we go. Okay. So make sure that you have your cluster running and your app is up and you have a deployment and a service exposed and all that stuff. And the first thing we'll do is let's just do a kube control get deployments and see what we have running. Get deployments. So I still have the bootcamp running, and there should be one pod. So let's do a get pods and see I've got one pod. Okay, one of one is ready. So then there's this thing I was talking about called replica sets, right? So if you just do get rs, that'll show you replica set. So my desired count is 1. I currently have 1, and there's 1 ready. It's possible to have one not ready, like if it's provisioning or if it's tearing down or whatever. But then the name of the replica set is always formatted with the deployment name, right, and then some random string. The random string is randomly generated and uses the pod template hash as something called a seed. So the two important columns are desired and current, which I think I just explained, but I think you get it. So let's say we want 4. So there's a command called scale. So you can just run kube control scale, and then we'll want deployments is Kubernetes dash bootcamp, and then we're just going to do dash dash replicas equals 4. And it says deployment.app/Kubernetes-bootcamp scaled. So now we can list the deployments again, and let's do get deployments. And we can see we have ready 4 of 4, up to date 4, available 4. And we should have 4 instances of the app available, and we can check the number of pods and say kube control get pods, and then I'm just going to go -o wide so it's easier to see. Did you mean yes, get? That's what I meant. There we go. All right. So now that gives us some wider output that makes it easier to see, but you can see I actually have 4 pods. So I have one container, and we're talking about atomic, right? The pods are atomic in Kubernetes. So we have one pod running one container at a time, and we desired state is 4. So instead of making 4 containers in one pod, it created 4 pods of one container. Now, if you're doing this on multiple nodes, which you'll remember we're just on one node, but if we have multiple nodes in this cluster, if one of the nodes went down, say an EC2 instance went down, or was getting a Windows, or you're doing a Windows patching if it was on Windows, or doing a kernel update in Linux, or you just needed to kill it off and restart it for whatever reason, or create a new one, that these 4 pods would be distributed by Kubernetes automatically to the available nodes based on resource management, right? So now we have 4 pods. They have 4 completely different IP addresses. The change is registered in the deployment events log, and we can check that by saying kube control describe, and then we want to do deployment slash Kubernetes dash bootcamp, and we can see that's a lot of text, but you can see in the logs here what's going on. You can see scaling up replica set to 1, and then we did our scaling event, and it says scaling replica set scaled up to 4. Okay, so now you're going to want to look at load balancing, right? So we need to check the service is load balancing the traffic. To find out the exposed IP and port, you can use a describe service just like we did before. So I'm going to clear this screen, and I'm just going to say kube control describe well, let's see. Yeah, we'll do that one again so you can see the exposed. We'll look at this really quick and see what's exposed. So in here, we want to create an environment variable for the node port. So I'm just going to grab the same command I ran last time and just paste it in here. Maybe not, maybe not. Paste, export node. Yep, that guy, echo the node. So it's the same command I ran last time. And then we can do the curl command, and we can say curl $parenthesis minikube IP on port node port. Hello Kubernetes running on, and then there's our pod. And if we look at our deployments and pods and all that stuff, you can be like, well, what is this the name of, right? So if you keep running this command, you'll see that this little guy here at the end, this changes, right? So what is it that we're looking at, and why is it changing, and what is this, and why is that staying the same? So it's a good question. It's a good question. So if we run kube control get nodes, look at the name of our node. So we have a minikube node. Okay, that's fine. So let's get our pods. So we can see these all have the same name. Remember this little guy right here? This is your seed. So then if we do the get describe deployments, we can see that this is the name, right? But the replica set has this actual name right here. So if I do kube control get replica set, you can see the whole name of the whole thing. So there you go. So that's what that is. Let's see. So let's try scaling down. So I'm going to clear my screen, and let's say we want to say same command, kube control scale. And in fact, I can go up and just use the same command. I'm going to show you that I'm using the same command. Let's see, doesn't have a search scale. So all I need to do is change the command from 4 to 2. And if I do this, it says it's scaled. Now, scale doesn't mean going up, right? You can scale in and you can scale out. In this case, scaling up would be not correct. So scaling out was the replicas 4. We changed it to 2, so it's going to be scaling in. So we can run kube control get deployments and see, now we have 2 of 2 ready, 2 up to date, 2 available. And if I check the pods, let's try kube control get pods output wide. You can see that I have 2 that are terminating and 2 that are running. And that confirms that 2 of the pods were in fact terminated. So that is it. If you have any questions on scaling applications in Kubernetes, let me know. It's fairly straightforward. Hopefully this demystifies some of the scary Kubernetes things that you've heard, and I look forward to doing more.